Welcome back to the bench, and today we got the EMS sequencer. It's getting close to having done all the EMS range. It's not quite on the bench because it's so big, and I'm just trying to figure out how I get to everything. But if I try and power on, see if I get my arm out of the way, the Nixie tubes flash up and then fade out. I can press clear, but nothing happens when you press start or stop. So obviously I think the power supply needs looking at. Let me just turn it around and show you the back. So this is the back where we've got all the cards to make up the circuitry. This is the power supply here, and we have another panel with some extra connections. And looking through the gap here, I don't know how long the cable is from the front panel. So let me spin it back round. And I'm going to try and take this front panel. There's only 4 screws, and then we can see how long the cable is connecting the front panel to the chassis there. I just noticed there's 2 X's on the first A and B output sockets, so might have to do some further work if we can get the whole thing powered up. But now the front panel okay, I'm not gonna, let me just show you the inside. So that's the back of the front panel. There's the Nixie tube and its circuitry. And then there we have the 19-inch rack housing all the cards. You can see the bus planes, they're obviously the power. And looks like all the wires go to this connector and the edge connector. We have the heart of the sequencer. This is the edge connector that was plugged into the backboard, made by Nestor Electronics Limited. And it does look like it tells us where the live and neutral goes to the mains. I'm going to have to double check that on the box itself. We've got the -15, -12, +12, +5. I don't see the high tension voltage marked out anywhere. So I don't know if that's happening in the rack or this is supplying it. I guess we'll find out. I mean, there's only 4 boards in here. So I suspect, and there's this transistor. There's another transformer here. It's possible that could go to a bridge rectifier somewhere in there to do the high DC voltage for the Nixie tubes. So the obvious thing is to check all these caps out. Really old, and I think I can just take this bar out and then slide the cards out carefully. We don't want to damage any of the connectors. these are the power supplies. We can check all the bridge rectifiers in the caps. So I've gone through and checked all the caps. They're all kind of all over the place. That's 5 microfarad as opposed to 15. This was in a circuit and leaky. So I think I'm just going to replace all the caps and then we'll test some voltages. Okay, don't try this at home, but I've hot wired the AC mains onto the connector and I can power it through my light bulb current limiter. And we can check the voltages. So we have our +5, another +5 on that pin. This should be +12, -12, -5. So all the power rails are there, and if we come down to the 3rd pin along, should be our high voltage rail to the Nixie tubes. Look, 184 volts DC. So all voltages seem correct on the power supply. Okay, let's see what happens now we've refreshed that power supply. Ooh. This light isn't flashing in real life, it's just steady on. But the Nixie tube's working. Oh, I can even reset. Looks like the sequence is working. Can I go backwards? Yeah. And stop it. Perfect. Start. This is looking good. So, from when we got this unit, can you see there's 1, 2, 3 sockets that have got crosses on them. So we'll have to see now if these are going to work. Well, that is a brilliant start. Does the speed work? There, we can slow it down. We can speed it up. That Nixie tube's flashing very fast. Okay, so I think I'm going to have to learn how to use this now. So join me in the next episode where we see what's going on with these sockets, and we'll find out if I've learned how to use this thing. So catch you next time.